So let's start. Thank you so much for being here. It is my pleasure to introduce the paper session number 8. I am Ines Cain from Artem Solution, and this is going to be our agenda today. So we will start with a presentation from Jérémy Clero from the IEECP on life in plan, how integrated spatial planning can help building the sustainable city of... Oh, is it? Sorry, what? Of tomorrow. Sounds good. Then we will continue with a presentation from Niall Buckley from IES R&D, Minority Report, Mitigating Environmental Disruptive Events Using People-Centric Predictive Technologies to Improve Disaster and Climate Resilience. Then we will have a presentation from Luciano De Tommasi from International Energy Research Center, validation of a smart energy service for the commercial rented sector in Ireland, Spain, and I'm sorry, we don't know. And Greece. Thank you. And we will finish with a presentation by Nitesh Karmasharia from ArcelorMittal. SmartSheetPile, Smart, Sustainable and Resilient Solution for Health Monitoring of Structures made of steel sheet piles. So, yes, we can perhaps start with Jérémy Clero.
Do we have a standing mic, or is it this one?
It's this one.
Okay. Then I will sit. Where is my slideshow?
Your slides, sure. Which one is it?
In plan here.
There, and you can use the mouse.
All right. All right. Good afternoon, everyone. My name is Jérémy Clero, and I work for the Institute of European Energy and Climate Policy. And together with my team, we are co-coordinating the project, the LIFE-funded in-plan project. We are co-coordinating it with the Northwest Energy Agency of Croatia, REGEA. And today I will explain you how we try to make binding energy and climate plans through the integration with spatial plans. It started from a statement and wondering, what do local actors lack of? So the capacity and mechanism to enact and enforce binding and energy and climate policies at local level, integration and alignment of strategies and policies, systematic integrated approach for energy and climate plans, and alignment between the planning and the finances, the budget lines. So from that, how could we make them binding legally? And what's the interest of it? First is that if they are binding from one mandate to another, for example, in a municipality, it will not be questioned again in the next mandate. So it brings some stability in the overall energy and climate planning, so that people who decide to invest in it, people and companies and public bodies, don't see their investment going to the trash after 3 or 4 years. So it's also one of the most important parts of making them legally binding. How do we do so? Spatial and urban plans are legally binding. Energy and climate plans are not. So if we integrate them to the spatial plans, we can have part of or all of it binding. The objectives of the project then are threefold. Integrate the energy, climate, and spatial plannings. We can also add mobility, infrastructure, and other aspects if they fit the municipality's plan. Empower and build up capacity in participating local governments at different governance levels. So what I mean with this, municipality, in some countries, for example, if I take France, departments, regions, it can go down, if we take Portugal, to the parish level. That is also one of the most local levels there. We try to involve them all. And matching measures with local and regional budget lines, again. We need to finance that. All of this comes together to develop the in-plan practice that is a structure for integrated planning, a guide that will support local governments into integrating their plans. We have 5 participating countries. We have Ireland, Sweden, Romania, Croatia, and Italy. What is the in-plan practice? It's a 6-step to successful integration, and it starts by creating the governance structure and the plan. We go through everything that exists, and we assess if it is structured to be able to go through this planning process. We assess the local context for opportunities and barriers. We review the existing plans, and then we ensure consistency between these different plans. Then we start engaging stakeholders and citizens from the very beginning, participation, consultation, feedback loops, so that they are involved from the very beginning and no one feels left behind. 4th step, we use the data. We define data collection and management plan, once again, to ensure consistency. This is not the core of this plan, but we relate to other projects that are data focused and that are highly specialized in data consistency and data sharing. Creation of the plan, 5th step, and then adoption and implementation as a last. The second pillar of this project is the capacity building and replication scheme. We have 4 key actors in there. We have the lighthouses. They are far ahead cities integrating energy and climate to spatial plans. From the beginning of the project, they are already advanced. So we built on their expertise to draft the in-plan practice. We have 3 lighthouse cities in each country. From that, we have this first draft. We will train pilot cities in the same countries that are not that advanced in their integrated planning. We will support them to put the practice in motion, in place, and in turn, they will give feedback so that we refine the in-plan practice. This in-plan practice, we will teach it to what we call multipliers, so energy, climate, or development agencies in these countries, but not only, all over Europe and also out of Europe. The target for this project is at least 30. We are mid-project, we are already at 38. So there is an interest, there is a real interest. In turn, the multipliers, they will multiply, they will replicate, they will train what we call the replicators. Replicators, we don't have any link. The project has no link with them. There are only local authorities in the vicinity of multipliers, of energy agencies, and they will be taught how to use this guide if they feel the need, if they want to follow that path. But this, we will just keep track of them from a project perspective, but we don't interact directly with them. So far, the pilot feedback that came to nourish our reflections on the in-plan practice is that there is a lack of tools and mechanisms to implement and enforce the plans. There is a lot of silo thinking in the municipalities because they are structured in departments. So you have the energy, you have the roads, you have, okay. These departments too often don't talk to each other. So it's a first barrier to remove, but this, we kind of knew it already. Difficulties to exchange with other governments level. This really depends on each country, but it's something that came back to us in each one of the 5 countries. So we need to hear it. And large cities struggling to exchange with national level. Sometimes they lack the channels with the national authorities because they are considered as local entities, and local is not national. So they miss the communication channels. Then we have the consideration of other plans in the drafting process that is linked to the silo thinking in the different departments in the cities. And to finish, the importance of data management, that is a whole part of the planning process, and that the in-plan practice is recommending about in this final stage. First achievement so far, halfway through the in-plan practice with the project team support in Zagreb and Karlovac in Croatia that developed suburban spatial plans, including energy and climate criteria within the covered zones, which became our first proof of concept for the project and for the practice. To tell you quickly about Karlovac, it was a city-initiated plan, and initially they wanted to create a district heating area. Okay. With the project, we told them, maybe you can aim a bit higher and integrate more component to your initial plan to go for more integrated green spatial plan development. They followed 3 basic rules, is that political will must be ensured from initial steps, continuous communication with city officials at all time, and public presentation and consultation and feedback so that everybody is on board. From this willingness to develop, they first tested it in a brownfield, so it's an old military base that they renovated. And following this, it was rather successful. They integrated elements of it to the general urban plan of the city. The process, I will go quickly on that one, but basically they started from the guidelines for integration of energy and climate measures. They did the spatial energy analysis, the overall energy and climate concept to reach concrete measures that they integrated to the spatial planning to develop their spatial plan. The key measures about in the planning against climate change, they are mitigation, so the usual suspects, I would say, energy efficiency of buildings, heating and cooling supply, street lighting. All right. Then we come to adaptation. This part takes a bit, even more planning than just renovating your street lighting or insulating buildings. It's the overall aspect of your infrastructure, how you integrate, for example, biodiversity, how you fight against urban heat island, what I write here, urban fresh islands instead, and which is becoming even more a current topic these days. We saw the summer we just had. Water management, floods and landslides. Again, now the after season, we have floods everywhere, so it's, I would say, it's today's considerations. And the mobility. And in this, they insisted on what they call mobility at rest, so the parking spots, the charging stations, how you develop the a better transport infrastructure that is initially based and thought for cars. So they integrated all this in their plan. Now the Karlovac is still in the pilot phase, so we don't have the results of it. You will have to come back, I'm afraid. But the second achievement in these 2 years of project is on the training multipliers. As I told you, we have trained 38 professionals already from 25 organizations from 12 countries, including one non-EU, that is Moldova. Here, if there is any one of you that is from a local authority and wants to, or an energy agency, energy or climate agency, please scan the QR code and join us, become a multiplier. It's always welcome. The third and last pillar is the policy feedback and institutionalization. From the feedback we gathered from implementation sites, we have 3 different bodies in the project. We have the institutional partners, such as ourselves, IEECP, FEDAREN, the European Federation of Regional Energy Agencies, and Urban Innovation Vienna. We have these European coalition groups that consist of the regional partners we have, and we try to have one lighthouse, so the advanced cities, to contribute in that for advocacy, and to have the same concept at national level, so with regional partners, lighthouse, and maybe multipliers, to advocate for integration, plan integration in their own country at EU level. And on the top of that, us institutional partners, we develop policy recommendations for EU level, but also in link with the national level. What will be the next step now? The in-plan practice is almost finalized. I will be doing the final reviews in my train back, if you want to know everything. We will keep implementing it in the pilot cities. We'll continue with the train-the-trainer sessions and with the replication scheme. While when we take care of the policy aspect of it, we will develop the EU and national coalitions to reinforce the advocacy for more integrated planning, and we will turn the feedback from pilots into policy recommendations at EU level especially. And on the top of that, we try to make it be known, so this is why I am here today, and on that, I thank you for your attention. Thanks. And become an in-plan multiplier, scan it.
Thank you very much. And we will continue. I think we will keep the Q&A for the very end of the session if we have time. So we will continue now with the second presentation from Niall Buckley. Which one?
The second one, smart. No, top one. Sorry, top one.
This one?
Yeah, the minority report.
No.
Oh, no.
Okay.
Yeah, that one there. Excellent.
You can click here.
Yeah, excellent. Yeah, this won't be too long. Relatively short presentation. The project's only a few months in, so we're just trying to advertise where we're going and let people know that it's happening. So Minority Report has a long-winded name like most projects, but the idea was to capture that movie by Tom Cruise where he's predicting crimes before they happen in order to prevent them. So under the same principle,
with IES and partners, we're leveraging our digital twin tools, combination of building scale, neighborhood scale, and city scale tools to evaluate different policies and different strategies to mitigate risk risk of, or essentially build resilience is what we're doing. With the new push of new technologies from distributed energy systems like renewable systems to new strategies of connectivity, we're during a climate disruptive event, we can have we can kind of keep in touch and keep the lights on during these events. It's about where's best to apply that type of technology in order to keep everyone safe and to keep everyone connected and to keep the lights on when there's an earthquake, forest fire, or flooding. So with IES, we've been working with partners across Europe for the most part. It's over 60 cities that we've set up demo sites in. We've partnered with over 400 different institutions, and throughout this we've been developing this type of technology. So it's grounded or founded in different scales of urban fields, from architecture and engineering to even social science and environmental science. So the Minority Report focuses on 3 disruptive events, 3 specific, although we don't keep it down to those specific events. We'll look at different disruptive events that you can have, but the 3 pillar ones are flooding, earthquakes, and wildfires. So we're essentially taking 3 pilot sites. One is in Greece, in Patras. The second is in Wellington, in New Zealand, and the third is in Dublin, Ireland. So these 3 pilot sites demonstrate all those risks. So Dublin's pretty high on the list for flooding. Patras actually has flooding as well, funny enough, and has earthquakes. And then I guess Wellington's the holy grail, and it has all 3. We have all these different risks to keep in mind. The forest fire ones as well in Patras. So here's a spread of the partners. There's 16 altogether, 3 city municipalities, so Dublin, Patras, and Wellington, 5 universities and 8 private companies, all involved in different areas of social science, engineering, computer science, public representatives. We have climatologists and we have risks assessors from UCL, from their Department of Risk. So it's a nice spread. We believe some of the most strategically placed partners to really develop something of value or something meaningful. With New Zealand now as a new Horizon Europe project partner, it does make times tricky to meet up and talk. They're basically the opposite side of everything. So it's 11 hours behind, and they're in the winter when we're in the summer. So there's all sorts of daylight things, and what's the best time that suits everyone to have a call with meaningful conversation. So that's definitely been interesting. But all that being said, we have a strategy that we're going to apply to the project, which is the workflow here. So Minority Report will essentially take various different types of technology that IES have developed, as well as our partnering organizations that have the skills in both social science and climatology to develop a digital twin model that will make an effort or make an attempt to predict what assets, and in this case, mostly buildings and the grid, are at most risk of a disruptive event based on the locality. So whether it's an earthquake or a flooding event or an extreme weather event, which buildings are the most vulnerable. It takes that information and builds a baseline, and from this baseline, we assess the cost of damage to that area through different risk models from UCL, as well as other social scientists who run the project, and economic models that we run. And then we go, okay, let's change things to make it more resilient. And so we start virtually plugging in different aspects of storage, such as, say, batteries, photovoltaics, different architectures on the grid, as well as resilience in the buildings, so different building materials that help mitigate against these risks, as well as some behavioral schematics for, what to do in emergency, how to change behavior, how to assess risk. So combination of factors all pushed into the one, and then we run the model again. And then we make a prediction this time on how much money and how many lives and how fast can the system bounce back on an index that we're going to build. And so essentially we'll build a few scenarios and say, in the next 20 years, this is probably your most secure way of moving forward to mitigate any kind of risk of a disruptive event, such as forest fires, earthquakes, and whatnot. Essentially, there's already a paradigm shift in the grid and in utilities across most countries. With the disaggregation of, or the decentralization of the grid, where originally it would all just come from a power plant and be pushed down into all the consumers, we now have a new grid where we can generate and bi-directional flow of energy and generate locally to keep the lights on, to keep cars powered, to keep the hospitals running, the usual stuff. Often emergency backup was always a generator with petrol or oil or some fossil fuel. But with this disaggregation of the grid, it means the grid has a term that's in the field. It's called a self-healing grid, where something hits it, like a forest fire, and cuts you off from the main suppliers. You could still keep parts of it operational with other assets on the grid. So it's about strategically using these assets, or in this case, don't put all your eggs in the one basket. Then we take some of our sophisticated models that we have developed through IES and some of our partners to essentially assess flooding risk and different extreme weather events and earthquake risks, as well as forest fire risks. I'm repeating myself, but in different scenarios, so we can identify whereabouts on the grid or whereabouts in the communities are people most susceptible. Could be pretty much their height above sea level, the types of buildings they live in, how the network is connected. Is it just one linear part of the network? If that's hit, does everyone lose lights? And then we try estimate the costs of these events. We use various different tools, physics engines, socio-technical and technical systems to try estimate costs and damages, as well as how to predict what's the best way moving forward. And we back this up with data-driven models as we roll out IoT equipment. For instance, the bespoke ones we talk about here is seismic sensors in Greece and New Zealand, and then maybe various different APIs for predicting weather events based off forecasts and stuff. Nothing new or novel. We probably still, in this case, depend on the Met Office, but we will have our own sensors on the ground as well to kind of help validate the models. So we pull this all together in a digital interface, dashboards that help estimate and make assessments on all the data-driven models from the Internet of Things and bespoke sensors, and then decarbonisation strategy roadmaps and resilient roadmaps for city-scale building stock. And we basically add these together to a hybrid digital twin, which is data-driven and predictive, using these physics models that basically help predict what way the local area is impacted based on various different scenarios we run. And then this can help us basically put our best foot forward in terms of applying resilient strategies. And all of this is going to be then leveraged by social scientists on the ground and various applications we have. They're not quite living labs, but they're basically workshops set up to train local experts in using the tools and understanding how to leverage them to help community outreach. This also has an iterative feedback where we get feedback from the locality. It's not on this slide, but often in disaster events, there's a local knowledge that's always overlooked. A lot of engineers make assessments based on what they physically see, and they go, this is going to be a flood risk, and this is going to be a risk for say, wind. And they assess the area, and they put in their policy, and they suggest back to the experts and the decision makers in government. But often locals have a better in-depth knowledge because they might be living there for 50, 60 years, and they'd be like, well, actually, down there floods all the time. And it flooded back in '86. And that local knowledge that gets overlooked by the experts is something we want to try capture as well so we can have a kind of a iterative feedback to really capture all the risk, ones that often get overlooked. So it's it's basically big tools to help localities really build in resilience. So we've just started off. We started our stakeholder mapping, and we've launched our website. So it's pretty much from November onwards, it's going to be a sprint towards getting these tools up and running. But anyone's interested in it, anyone's interested in resiliency, feel free to reach out. And yeah, we're looking to kind of push out what we're trying to achieve here and expand with our projects. So that's it. Thanks very much.
Thank you. And we will continue with a presentation from Luciano De Tommasi.
Yes, thank you.
Which one is it?
SmartSpin.
Thank you. We click here.
Okay, thank you. I sit here. Okay, so my presentation is titled Validation of a Smart Energy Service for the Commercial Rented Sector in Ireland, Spain, and in Greece. And this is a particular task in the SmartSpin project that developed such a service, and the task is led by the IERC, so it's one of the concluding tasks. Actually, our project should have ended in August, but because it has been extended, this task is still undergoing. So in this presentation, I have some results, but some others have to come in the next 3 months. Okay, so the outline of my presentation is, first I'm going to review what the split incentive issue is and the SmartSpin concept, so how SmartSpin proposes to solve this issue. Then I'm going to talk about the validation of the business model that we have previously developed in the project. Then I'm going to talk about the division of energy cost savings between landlord, tenant, and ESCO, and the revenue streams for ESCO, the renters, which are the tenants, and the building owner, who is the landlord, the decision-making for the ESCO and the contractual agreements, one consideration on the contract duration, which is one of the barriers in this sector. Then I will go quickly through the key performance indicator at demonstration sites, and say something about the smart energy service implementation at the pilot sites, and then conclusions. The last 3 points will go very quickly through. So a split incentive occurs when the benefits of a transaction, for example, investment in energy efficiency measures, do not primarily accrue to the person who pays for it. And in particular, the Energy Efficiency Directive identifies that this is a barrier with respect to investment in energy efficiency because the parties, so the landlord and the tenant, may be deterred from making investments because none of them would take the full benefits of these investments. The landlord does not occupy the building, so the energy savings would be obtained by the tenants, and while the tenants do not own the spaces, so if they invest in energy efficiency, and they lose part of their investment because they don't own the premises. So the concept that the SmartSpin has proposed and we are validating is that the tenant pays for the energy consumed and also pays an energy efficiency provider for the energy saved. So if there is a reduction in the energy consumption or in the energy bill, this is somehow paid. So for this service, the tenant pays an energy efficiency provider, and the energy efficiency provider will share value with the building owner. And this is the mechanism that allows to incentivize the building owner and to incentivize them to invest in energy efficiency measures. The ESCO will also install and maintain the energy efficiency measures. These other two infographics show the two cases where the building owner is investing directly in energy efficiency measures, and the second case where the ESCO is actually liaising with a bank or a lender to get funding and invest in the measures. Service implementation, normally we think that this can be done in two periods. So in the first period, no cost or low cost measures are installed. And in the second period, medium or high cost measures are installed. So in the first period, only the tenants might be involved, because the landlord doesn't need to give permission if no works are performed in the building, but just better energy management. Whereas in the second case, the landlord will be involved. So as part of the validation and also as part of the activity that we performed in our project, we created the so-called business model canvas, which is a table that includes a number of sections. So we identify the key partners, the key activities, key resources, value proposition, the customer relationships, the channels to advertise the service, the customer segments, the cost structure, and the revenue streams. I'm not going to read all this information, but just focus maybe on the value proposition. What is the value proposition? To offer a comprehensive service to the clients such that they can be assisted in choosing energy efficiency measures. The ESCO will take responsibility for installing these measures and for guaranteeing a certain amount of savings for a number of years. This is the most common type of contract. It is also possible, though, that they would decide to share the savings according to certain proportion. But normally, when the client finances the project, they will go with the performance guarantee. And there are different customer segments ranging from industrial buildings, shopping centers, retail, offices. In the project, we have demonstrated the service in shopping centers and in office buildings mainly. The channels to advertise the service are the usual ones, so emails, the website, participations in events, in conferences, workshops, and of course there is a cost structure that consists in purchasing the energy efficiency measures, the energy efficient equipment, using consultants to implement the service, and the revenue streams come from the energy savings mainly, and the payment of for the ESCO, the payment from the tenants for the service. So in this second table, we see that the value proposition, how the value proposition matches the need customers' wants, needs, and fears. In particular, the customers want to have measures that are have the fear that the measures may not be affordable or the payback time is too long. So the ESCO can assist to select the right measures and also can assist to estimate and predict the energy savings such that their estimation is accurate, and it can also help, and it helps to maintain the measures at their best performances. So with the operation and maintenance is also part of the service. And also another fear could be that the investments are not justified because the costs cannot be recovered by the renters who would not pay for that. But this is exactly what the project is addressing with its business model. And I think this is, in a nutshell, the business model. I went very quickly because there is more material that I want to show you, and this is a bit more advanced now. So this is about the division of energy cost savings between landlord, tenant, and ESCO. One challenge for the ESCO is to understand the renters' behavior with respect to energy consumption and determine, based on their behavior, the division of savings between building owners and renters that maximize the value for the owner. Of course, the ESCO will advise on that, and then there is an agreement between the parties. So it has been observed in the literature that the actual savings are obtained by the energy savings potential of the project multiplied by an equipment degradation function, because after 25 years, this equipment will not be as efficient as when they are new. And by a term that is called the rebound effect multiplier, and it's the function that you see in these two figures. In the first figure, we show the dependency of this function by a parameter that is called the risk tolerance, and measures the attitude of the different renters with respect to the risk of getting energy savings. So participating in this process, and you see that if the magnitude of the risk parameter is very high, so this function will drop very rapidly to a point where that depends on the maximum rebound effect. And this has been plotted for different value of the risk attitude, whereas the second figure shows the dependency with the from the maximum rebound effect. And also in this case, if the rebound effect is more pronounced, there will be more savings that are lost if the landlord is taking a large fraction of the savings. In these figures, you will see the difference between the case where if there is no rebound effect, the optimal choice for the landlord is to take all the savings, because it will maximize in that way their net present value. Whereas in the case where the rebound effect is 20%, is the second figure, and the third is 30%, you see that this straight line becomes curved. So the value that maximize the net present value for the landlord is no longer 1, but it's convenient for the landlord to share some savings with the tenants, and that affects the decision making. The revenue streams can be calculated as follows. So QT are the actual savings. If we multiply by the energy cost, you get the value in euros or in dollars for the energy savings. And then we have 3 revenue streams: one for the ESCO, one for the renters, and one for the building owner. So in particular for the ESCO takes the whole revenue stream and subtract the 2 terms that are given to the clients, that are the renters and the building owner. And in this case, G is the guaranteed energy savings, and beta is the fraction. So if the savings are above the guaranteed saving threshold, they would share according to this proportion beta. And n, lowercase n is the contract duration. So you see from all of them that when the ESCO, especially from the first one, when the n is greater than lowercase n, so the ESCO is the contract with the ESCO is terminated, so the ESCO is not getting any savings, and the 2 clients will share the savings. So theta is the share, so between landlord and tenants. So landlord takes theta, and the renters take 1 minus theta. So we can calculate the net present value for the ESCO, for the renters, and for the building owner. I think here the recommendation is that building owner and ESCO would share the investment. IC is the capital investment. IOM are the operation and maintenance costs. And there are some interest rates applied to ESCO, renters, and building owner here. The fraction of the capital investment performed by the building owner can be between 0 and 1. So the approach would be to for the building owner, which is the main decision maker here, to look for maximization of their benefit, and maybe choosing the ESCO that provides the highest level of savings. But there is a budget constraint, of course, so they cannot pay more than IMAX C. And also the ESCO should have at least a minimum reward. So the building owner wants to reduce the contract duration because a longer duration would reduce the benefit for the building owner because the ESCO is taking some energy savings out of the energy savings of the project, of the energy efficiency project. The building owner wants to also reduce the fraction of the investment. So ideally, the building owner would like that the ESCO would bring the capital for the project. But this is not necessarily the best choice because then the ESCO would require a very long contractual duration. So if we increase the fraction of so the contribution of the landlord, so the contract duration will become lower, and that's good because these buildings are rented, so the renters could leave the building even before that the EPC contract is ended. So in these two graphs, a kind of sensitivity analysis with the parameters that determine the rebound effect were performed, and we see that this gives the minimum for each contract duration, the maximum fraction of the savings that the landlord could take to allow a net present value for the ESCO greater than 0. So we can see that if the contract duration is not very long, like 14, 15, 16, so the ESCO does not like that the building owner takes all the savings because that would create an increase in the renter's energy consumption and reduce the energy savings for everybody. So and may create even losses for the ESCO. So what's the barrier that SmartSpin wants to solve is the long contract duration. So one was the split incentive, and it is addressed by the business model. And the other barrier is the long contract duration, because in many cases, such contract duration for the smart energy service can be longer than the tenancy contract. So that's not convenient for the landlords and would be a reason for not entering into an energy performance contract. So in this case, we can see that from the graph, the graph shows the net present value for the ESCO. So we want to be positive and greater than a certain level. So if we have a short contract duration, like 5 years, then the ESCO can only provide a limited amount of capital. So in this case, around 40%. But if the contract duration is longer, then the ESCO can provide more capital. And if the contract duration is 15 years, so the ESCO, in this example, can provide about all the capital. So the parties need to negotiate the contract duration and the funding for the project such that the ESCO has sufficient margin, as positive net present value, and maybe a little bit greater than 0. Now, key performance indicators. We have demonstrated this business model in 3 pilot sites, in Ireland, in Spain, and in Greece. And each demo site has some targets in primary energy savings and reduction of greenhouse gases emissions and investment in sustainable energy. And let's say the achievement of these targets is one of the indicators that business model can be used in rented building, commercial rented buildings. So in Ireland, these are not yet the final numbers, but are the current estimation, which is very close, we think, to the final numbers. So in Ireland, these savings are slightly lower than planned, but in Greece, still the estimation is similar to what was planned. But in Spain, we have higher energy savings. In particular, we have installed a higher amount of renewable generation, and this allowed to exceed the target. And also the CO2 reduction has exceeded the target. The investments will need to be verified, but so because the primary savings are higher than the target, even if the investment would be lower, that would mean that the investment has been more effective than what was initially envisaged. So in total, we can say that the project has achieved its targets in terms of energy savings, in terms of, as determined in investments in energy efficiency across 3 pilot sites. So the business model has been effective in solving the split incentive issue. This is an example of recommendations for one pilot site. In this case, this is for the average renter because there are renters of different sites. The tenant before this project paid 629 euros per month, but after the project will pay 428 as energy bill, but they will also pay a certain amount, 181, to the efficiency provider, and the efficiency provider will share a part of this, so 121 euros with the building owner. This is the mechanism. So the building owner is happy because he gets a reward that supports his investment. The tenant pays a lower bill, and even if they pay a fee to the efficiency provider, the total is not exceeding the expenditure before the implementation of the service. And it is even it can be even a little bit smaller. In this case, 609 in total compared to 629. Okay, so they pay just a little bit less. Building owner gets rewarded. The efficiency provider gets rewarded for installing and measuring and maintaining energy efficiency measure. So this is a win-win-win situation. And okay, there are other examples for Plenilunio, another shopping mall in Spain, an office building in Greece. In Ireland, it is a bit different. It has been set up in a bit different way. So in this case, the tenants have not been involved yet, but because the landlord is occupying some spaces in the building, basically the efficiency provider is contracting with the landlord and is guaranteeing certain energy savings, and the landlord is paying a monthly fee, and this monthly fee will be reduced if the savings are not met, so it's performance contract. And in the future, the landlord will consider to get a payment from the tenants once that the savings are measured and assessed. The landlord is considering to get a payment from the tenant as a compensation for the investment in energy efficiency, which in this case has been performed using the sinking fund, so money that building owner had saved previously for this kind of intervention. Conclusions. So this presentation has discussed the key steps undertaken to validate a smart energy service suitable for commercial rented properties. As part of its validation, the SmartSpin business model has been refined and has been fine-tuned, considering both qualitative aspects and also its quantitative formulation. So the key performance indicators of the smart energy service and some implementation aspects have been reviewed, and the conclusion is that the service is effective in reducing the barrier of the split incentive in commercial rented buildings, and also reducing the barrier of long contract duration through an appropriate allocation of investment for the building owner and ESCO. Thank you. Thank you.
And we will finish with the last presentation. Yes. Would you like to tell me your name? Nitesh, and your last name? Karmacharya. Yes? I wanted to pronounce it correctly.
Yes.
Good afternoon, everyone. I hope you are all having a nice afternoon in this conference. And today I'm going to present about SmartSheetPiles. Originally, this was to be delivered by one of my colleagues, Abir. Unfortunately, she's not here, so I'm stepping up. So I hope I can give you a good introduction to the product. So before going into SmartSheetPile, just to give you a brief about what SteelSheetPile itself is. It's a hot-rolled steel sheets and with the interlock, and once with the arrangement properly, we can create a chain of wall. So this wall can be a retaining structures and can be used for several applications such as mobility and infrastructure, water transport solution, hazard protection and environment protection solution. We can use it for abutment, harbor walls, quay walls, and river training as well. So SmartSheetPiles means we are going to have structural health monitoring in the sheet pile itself. To do that, we equip this sheet pile with sensors. Once the sensors are active, we do data collection and we process the data to have predictive maintenance from it, or also assess the current situation of the wall. This gives us the current condition to give us idea if there is any damage. We can localize where the damage is and also find the parameters such as how we can further maintain it and also have a predictive maintenance. So what SmartSheetPile adds value to the current traditional sheet piles. It can help us secure the structure. We can have prevent damage and also some hazards. We can have proper maintenance. I remember one data from McKinsey, study from McKinsey that says that for every €1 spent today for predictive maintenance, we can save €5 in the future. So that adds a great value to our product. We can minimize unavailability. So for the maintenance, if something has to be stopped, it takes an enormous amount of time. If it's well planned and well organized, we can always run our projects and continue the maintenance as well. Also, with the digital help, we can find the proper capacity of our structures. So with the data collected, we can identify if we have overestimated the design, and also at certain places, we can really push to the capacity of the structure. So SmartSheetPile basically consists of 3 units. So one is hardware itself, so it's the sensors that's attached to the sheet pile. The data acquisition system, so this includes a data acquisition module and a networking module. Currently, we are planning to do it through 4G. And software, so it's a cloud platform where we can assess our data. Yeah. So right now, what are the things we are currently assessing through our SmartSheetPile? So our industry requirement includes corrosion, inclination, position, strain, anchor tension, soil pressure, also water pressure, shock and vibration, and load applied to it. So our system can have all or part of it according to the requirement of the project. It can also give information about surroundings such as tidal level of the soil settlement, inclination, and groundwater levels. So to demonstrate the capacity of the SmartSheetPile, we have already prepared a SmartSheetPile demonstrator. So this is a small sheet pile unit, and we have housed it in our ArcelorMittal office at Ash. In this, we have all the sensors active and running, through which we can see the present condition of the sheet pile behind. And this can also be accessed in our online monitoring. So this is a front end of one of the sessions where we are detecting shock. So here I think we hit it with a hammer to get a shock there. Likewise, bending is also computed here based on inclination and strain. So this can also be monitored. To check the robustness of our sensors, as SmartSheetPile goes through a very rough environmental conditions during installation, we have to drive it through the soil. So this test was done on October 2023, last year. And we checked the robustness of the sensor there. So when we drive a pair of SmartSheetPile with all the sensors housed in the box as seen in the diagram there, the wire ran through the tube, and all the sensors were running fine. The yellow boxes are just for checking the data acquisition system is running or not, so this is not part of the sensors. From our test, we found that all the sensors were working perfectly fine, and so driving both by viber driving and impact hammer driving both were working fine for the SmartSheetPiles. And next, we have also started a pilot project. So this is in Martert in Luxembourg as well. So here we have the goal was to add a new turning point, as seen in the figure there. And there we use a SmartSheetPile wall, and we have 4 pairs of SmartSheetPiles to be installed. Actually, it's already installed there, and we have already checked if signals are coming from all the sensors, and it's good. This project is soon to be finished. As I told you, there are 4 pairs of SmartSheetPiles, each connected to the junction box, and all the junction box will connect to a main electro cabinet through which data will be transferred to our online systems. So the next step would be to further have a development on data aspect of the project, and we are looking for collaborations with multiple partners. We are also developing algorithm for predictive maintenance. So yeah, that's a SmartSheetPile. Thank you.
Thank you very much to everybody, both speakers and attendees, online and on site. So we have time for questions. So you can write your questions in the chat if you are online, or I can take also questions on site. So there seems to be no questions, and we finished very, very early, and we can enjoy coffee and pastries. So thank you again. It's been a pleasure, and enjoy sustainable places.